My name is Kevin Miller. I'm a program manager in the Azure IoT team, and I'm going to be your tour guide for a little bit of a tour of how we think about Internet of Things solutions on Azure. And part of that is, I swear, the only piece of technology that I consistently have trouble with is one of these clickers. Fine, the space bar is my friend. Okay, so I want to talk about the space, but I want to start by kind of setting it up and saying there is, wow, a lot of hype here. I've been in the industry for a long time. I have been through quite a few versions of, wow, this is going to change everything. And the buzz around Internet of Things is crazy. And part of what I want to talk about today is a little bit of reality injection, I hope, to help you make some rational decisions. And part of this is based on my experience over the last year or so in talking to a lot of customers, building some of these things myself, learning a lot, and also kind of having that horrible thing where you go, wow, there's a lot of people saying things that really they shouldn't be allowed to say in public. I had a vendor visit me about 3 weeks ago, and they told me that their solution had infinite scalability and perfect security. And the guy didn't smile. I thought it was a joke. I started to laugh, and then it was that really awkward moment when I thought, oh my God, he's serious, and his company lets him go out in public. And so, yeah, you have to keep this in mind, right? The security comment, that one just really kind of killed me, because obviously you can't have perfect security on anything that has a human being involved in it. So I want to spend some time. I'm going to build some stuff. Mostly, the building part of this, I'm going to use things that have already been released. And then I'll do a second demo where I do a little bit more future-facing. And I'll talk a little bit about how you get from what you can build today to be ready to use what we're going to build over the coming months. So, wrong space bar. So, one of the things that comes up pretty much every time I talk to a customer or partner or anybody about Internet of Things is this really anything new at all? And I tend to get one of two answers. I either get the answer that says, come on, we've been doing this forever. And there's some truth in that. If you think about the space program, if you think about what's being done with airlines for many years, there's a lot of very sophisticated command and control out there, and that is very closely related to Internet of Things. And the other people that you hear want to tell you that it's a magic unicorn. And you just have to walk along behind it and pick up the gems that come out of its butt, right? It's a magic, wow, it's the perfect security and infinite scale guy. You don't have to do anything. This is just going to magically transform your business and make magic everywhere. And the reality is, if you want to do Internet of Things, you have to saddle up. You can't, vendor that out and think you're going to have a good experience, because it requires that you think about problems maybe that you've thought were pretty well solved for a long time. And it requires you to rethink those. It requires your entire organization to become pretty relentless about security. Because once you connect devices and people over the internet, something that might not have seemed like an interesting target for a hacker in the past, all of a sudden is. And I'll talk more about this. But I would say that the truth is, not surprisingly, somewhere between these two extremes. If you have the will to do it and you saddle up, you can make transformative change with these technologies. You can change your business. You can find, new revenues that you didn't know were there. You can find efficiencies that were not obvious. There is there, but you have to be a realist and you have to really sign up to do some stuff. So I mentioned the airplane, rocketry, command and control thing a minute ago, and I think there probably should be a pool on how many times anybody giving one of these presentations says the word thing. But I would say that the state of the art up until around now is that there were really two kind of solutions that were possible for Internet of Things. And they were both not really that many instances. On the one extreme, you had something like a rocket or an airplane, something where the thing was really, really expensive, or the cost of the thing failing was astronomical, was unthinkable. You couldn't even go, oh, fine, it crashed, but you can't even begin to put a value on that sort of thing. So if you think about that sort of solution, well, the thing is expensive, the cost of it failing is astronomical, inconceivable. You can put some extra cost. You can put a lot of extra cost in that, if that's the scenario. And so that's kind of where one part of the Internet of Things industry is, building these custom solutions for super expensive things. Now, if the thing is not super expensive, it's hard to justify the cost of sensors and software and everything for a custom-built one-off solution. And at the other extreme, we have very simple objects, and the canonical example that everybody thinks about is a thermostat. So a thermostat is cheap, but it's really simple. Maybe it can do 3 tasks. It can tell you what the temperature is, it can tell you what the temperature was supposed to be, and it can set a new supposed to be temperature. And so that thing is pretty simple, and doing the analysis on a thing like that is really easy as a general rule. If you have thermostats in refrigerators, and 98% of them say the temperature is between 38 and 42 degrees Fahrenheit, and 2% of them say it's 72, it does not take an analytical genius to figure out which one's probably broken or turned off. And so, again, these are pretty accomplishable now because the analysis is easy. They tend to be all the same, and that homogeneity means that you can do the analysis, you can amortize the cost of the software across a large number of units. And especially when the analysis is relatively easy, you're not amortizing a lot of analysis over those. So I would say that the challenge for Microsoft, and really for our entire industry, is to make it much easier for customers and partners to move toward the middle. To do analysis when the things are more complicated than thermostats. To build solutions that do not require so much custom work that you can only justify it for a very expensive object. And that's really, at some level, that's the classic Microsoft playbook. We're trying to move something that is historically custom into a more mainstream position. So now to kind of flip this around from some of the opportunity and the challenges and maybe the way that some people are thinking about this to what it means for someone who is in the classic IT world. And there was this joke a few years ago that said if you're like in middle management and you're not confused, you're not paying attention. Well, this is sort of the IT corollary of that for the Internet of Things. If you're looking at these Internet of Things solutions and you're not a little nervous, then you're not paying attention. Because you have these continually growing challenges. One of them is scale. And at scale, like a few years ago, you could kind of assume that the number of objects that you had to deal with from IT was roughly the same size as the number of people. And you could think about things like Active Directory that were really designed to associate a user object with a machine object. OMA does the same thing in the mobile space, where they're trying to associate a cell phone to a person. Well, all of a sudden you're in this case where the number of devices is growing super fast. It's growing much faster than the number of users. And you get to the point where it's hard to make an association, or silly to make an association between the object and a user. Like, who is the user object that owns the thermostat, or the lighting, or the air conditioning, or the projection equipment in here? It doesn't really make sense. From an administrative standpoint, you want to say, okay, this person has rights to do things to that stuff, but you don't really, other than that, associate those things with the user object. And then the amount of data and network traffic, of course, is ridiculous. So, and it's not going to get slower or smaller. And then you have, so in addition to scale, you have things around, how do I think about the pace that I've expected to do things at? And that's partially innovation pressure, where somebody is saying, no, we have to do, last year's stuff, we have to do that with, 15% less resources. Some of it is, oh, you know what? Now that we're doing analysis, we're starting to learn about our products more. Now we want to start taking actions against them. So all of a sudden, there's this pressure around, okay, how do I think about it? How do I analyze it? How do I do command and control to it? And then how do I find these people that suddenly I need that I didn't even know existed? Like, there might have been people called data scientists 5 years ago, but all of a sudden, every company that I know is trying to build a data science team, and it's how you think about that. And then the platform piece. The Microsoft homegrown example of this is that we have been very Windows-centric for a long time. And now, if you look across the Cloud and Enterprise division, we are doing a lot of close partnerships with Linux. Some of the Linux vendors are among our closest partners now, which is a real change for us. It was also kind of a skill gap for us. I mean, we've always had pockets of people who knew Mac or who knew Linux. Now, all of a sudden, that's becoming a really common requirement, because there's a lot of Linux, there's a lot of Android on these Internet of Things. So there's that sort of skill gap thing, and then the environment in which you have to work changes. We had the luxury for a long time in software of not having to worry about something that we did hurting or killing a person. And now with Internet of Things, connected vehicles, connected everythings, it's a different environment. And now, there's a requirement that more of a collaboration between IT and OT. And really, you kind of can't solve these problems without both. You need people who have been thinking about physical safety combined with people who've been thinking about net security. And you need that combination. And a lot of companies haven't really had much IT-OT collaboration in the past. I'll talk a lot more about security and privacy as we go along, but as you well know, once something is internet-facing, you are in a whole different world when it comes to security, and you really have to think about that differently. I have been kind of personally stunned by how many standards bodies there are, and new standards for protocols and firmware, and it just seems like every day I uncover some new standard that I didn't even know existed. And now you also have people competing with you that maybe you'd never thought of competing with you before. I don't know if 5 years ago anybody at Honeywell would have said, yeah, we're going to be competing on thermostats with Google. Maybe, but that one, that's one of those ones where I looked at it and go, wow, did not see that one coming. And so that's another thing that this sort of ubiquity of computing puts you in a very different environment. Okay, so let me just build this in and talk to it. Hold on. So if any of you saw Sam George's talk on Monday, I did steal this slide from Sam. So some of you may have seen this before. But this is sort of how Microsoft thinks about the pattern for devices and cloud connectivity. So on the far left there, you have this universe of devices. And I'll come back to this in a moment, but these devices are extremely different from each other. You have very low-powered things that, I wouldn't even I certainly wouldn't call it a platform. It doesn't really have an operating system on it, a thermostat. Some of these systems are super low power. And then you have full-fledged PCs, and then you have logical collections of things where the thing is really a composite. An example might be a truck on a highway that's delivering packages. There's information about the truck, there's information about the packages and the locations of the packages, which hopefully it inherits from the truck. There might be sensors in the package that are measuring, say, the ripeness of fruits or vegetables that are being shipped or whatever. But the idea is that at some level, sometimes you want to treat that as a logical entity, as a single entity that's composed of a bunch of other entities. So this device universe on the left is really rich. I think of it at the bottom, the simpler devices. These are not devices that you would want to plug into the internet. They would be hacked or overrun or killed by hamster videos within a few minutes of being connected. And they probably lack the sophistication to be really securable. In order to do good security, you need to be able to generate truly random numbers. And a lot of the less powerful devices just simply can't do that. So devices like that, you might want a field gateway on the other end of. Then sort of in the middle, you might have systems that speak protocols that Microsoft does not understand or very proprietary to a specific industry. And in those cases, you might want to have a protocol converter that converts from one system to another. This is the C3PO language of moisture evaporators joke that I just passed by. And then at the top, you have these complex systems that can, in fact, fend for themselves on the internet, can be connected, and can go right in. So data coming in, commands going out, possibly through some sort of field gateway or protocol adapter. Then once the data is in, you want to do analysis on it. And I made a wisecrack about batch being cool again now, I think. Because now batch is called cold path analytics. But you can kind of think about that as, I've got a bunch of data, I want to chug through the data, and I'll make some decisions based on that data, and those decisions might drive the design of the next product. They might drive decisions about how I route trucks. These are things that, generally speaking, can be calculated offline, so it's batch. There's a lot of power there, but it's batch. And then what we call hot path analytics is when I want to make decisions based on the data while it's in flight. And so things like Stream Analytics or HD Insight Storm fall in here, where I'm looking at the data in real time, making decisions, making routing decisions or whatever. And then finally, this hot path business logic is the idea that I want to be able to write meaningful business logic against these things, even if the thing is that complex logical construct. So the example that I often use is a conference room, because everybody understands what a conference room is. Sometimes when you write business logic against a conference room, you want to be able to say things like, building 43 dot conference room 22 dot projector dot off. And so the idea of being able to use some sort of object-oriented feeling or actor-based model where you can deal with the abstraction layer that you need to. You don't always have to go to the bottom level. Like in that example that I just gave of the projector, if you don't have that logical structure of the buildings and the conference rooms and stuff, you end up doing searches on tables of projectors looking for the one that has the metadata that says it's in room 22. And that search only works if whoever last serviced that projector or installed it typed the metadata incorrectly, because you can't otherwise figure it out. So you have this horrible stale metadata problem that we've all seen many times over the years, where somebody made a change to something, now I can't find it again. I was talking to a customer a few months ago that does subway cars. They build subway cars. And one of their problems is, like, if they replace the motor that opens and closes the doors, and the tech basically has to type in, okay, I put this motor in this car, because the sensors are on the motor housing. And if they fat finger that or forget to do it or whatever, and then later on that motor fails and starts squealing to home and saying, come fix me, they have no idea where it is, because they're relying on that metadata instead of on the structure of the data and being able to infer the location. So that's a big challenge for the whole industry now, I think, is around how we provide programming models that allow you to deal with these things at the right abstraction level. And then on the far right side, then how you think about showing the data or acting on the data, how you view it, how you write programming actions against it, how you fire off based on events. Okay, I want to fire off a workflow that, to a ticketing system that causes the tech to be sent, for example. Okay, so that's sort of the way we think about the problem. And then if you think about the Azure services that go into creating solutions there, well, there's a lot of technology options around things like Event Hub for getting data in, the just recently announced IoT Hub for getting command and control back out, lots of options for storage, blobs, SQL, Azure DocDB, a lot of options there. Analytics, all the way from machine learning to things that take place more or less in real time, like Stream Analytics or HD Insight. And then, okay, something like Power BI to look at the data, BizTalk for business integration, system integration. And really, a lot of what we're trying to do is we're trying to make it much easier to figure out what you need. Because right now it's a little daunting. The first thing you come in the door and you go is, okay, I've got a lot of choices. How do I think about which ones are the most appropriate? And I'll come back to that. But first I want to talk a little bit about one of these patterns. And I'll go through a few of these during the course of this talk. But these are patterns for thinking about IoT that come out of a lot of conversations with customers who have either done this well or done this poorly, and our own experimentation. And the first pattern, and I think this one's really important, is you need to think big when you start looking at IoT, but it's very important to start small. So, and part of the reason is it's almost a guarantee that you will discover things about your company, about your systems, about your products, about the data that's actually helpful that you did not expect. You will find there will be some free money where you'll go, holy cow, that was really cool. And there'll be some places where you go, oh, God, we didn't think of this. And if you find these sorts of things when it's a small number of devices, when you're in early days, it is way, way, way easier to address them. And so here's a kind of a silly example that makes me happy. If you think about a thing like a car, and you want to build an app for the car that lets you remotely start it, for instance, from your phone, or unlock it. What happens when you sell the car? Right? If I sell my car to somebody, can I still walk up to it and start it just to freak them out? And that's an example of one of those things that if you discover that early, when you're doing a prototype and you have a few cars, it's really easy to address. And if you wait till you have 1 million cars on the highway and then you go, we didn't think about the selling and the what that means to the app, then that's a nightmare scenario. Right? And I think at least one of the major car companies almost blew this. Like they were fairly far along and then he went, oh God. Right? And this kind of comes back to this, and I'll come back to this some of the security and privacy implications of this as I go on. But it's just a simple example, right? That you have to, you're going to find stuff that you didn't expect, pretty much guaranteed. And so it's way easier to work through these things. It's also way easier to work through security and privacy at a small scale, because you're going to find out that you might be an attack target now where you weren't before, and working through those issues. How do I manage the devices? Another great one to do when you still have a few of the devices and your design on the devices is not locked. And so the anti-pattern here is just like hold your nose and jump in and hope for the best. But we have had the example of customers come to us and go, hey, so we deployed tens of thousands of these things, and how do we manage them? And it's like, well, the first thing you need to do is build a time machine and go back to before you deployed tens of thousands of them and think about management. And that's really not the message that anybody wants to hear. So when we build our architecture and when we think about IoT, we have a number of these design considerations that are really important to us and we think about all the time. One of them is that you have to be able to make sure that you can manage this extreme heterogeneity. The devices are just all over the map. At some level, it's kind of amazing how powerful even some of these maker devices are. But you have this continuing push in both directions. Incredibly sophisticated devices and incredibly unsophisticated devices. And the software on them, there are some that are so simplistic that they didn't really have an operating system. They have a little firmware. You very quickly get into the firmware management business, and if you don't have scars from that yet, welcome. Then you have to think about, from our perspective, we have to think about how do we handle massive, massive scale, super high data inputs. We measure Event Hub message input in trillions of messages now, not billions or millions. And at the same time, how do you support that while at the same time providing a low latency command and control? Because you usually have to optimize for either throughput or latency. And so in this case, we've spent a lot of time trying to balance that so we can say, yes, we want to bring in huge amounts of data to event hubs. When we send a command back, we want that command to go out with low latency, and we want the acknowledgement that the command was successful to come back with low latency. A silly example is if you're trying to unlock your car, you don't want an arbitrary pause before it actually unlocks. A more serious one is if you're trying to send a command to a piece of machinery, a very delicate machinery where milliseconds matter, then you have to be really relentless about that. And on Friday, there's a talk by Clemens Vasters on security. He's going to go into the security stuff in a lot more detail than I am today. But I can't really overemphasize how important it is to think about security from the beginning and practice defense in depth, where you're looking at the devices from the moment of design on, and you're thinking, how do I secure this thing in a very rough and tumble world? How do I make sure that the device knows when, the device itself knows when it should or should not accept commands? And then this is sort of the classic Microsoft how we succeed. We want to make it a lot easier to go from evaluation through prototyping and proofs of concepts all the way to final deployment. Some of you have probably seen the Power BI demos around the conference. This is part of this, how you think about these things differently, how we have to provide tools that allow you to look at data at these enormous scales. If you have 1 million devices sending information, showing you a table view of that is really not very helpful. And so we have to be smart about how we bring the telemetry in, how we analyze it, and also how we show it. And then I already talked a little bit about analytics and responses. So my second pattern, and then I'll get onto my demo, I think, but my second pattern here is that in addition to starting small, it's really, really, really good idea to start with telemetry only. And there's a couple of reasons for this. One of the reasons is that you're very likely to find insights in the data that you didn't expect. And I mean, sort of by definition, machine learning finds things that people didn't notice. And in a very large number of cases, the data that people thought was really important when they start one of these projects turns out to not really be correlated to anything. And some piece of data that nobody thought was really all that important turns out to be the critical one that predicts whether the engine is going to fail. And so by starting with telemetry, then you have that, you can focus on that and understand what you really have before you try to make it actionable. And it also gives you an opportunity to think about telemetry in two ways. One is like telemetry that you're gathering from the device, and the second one is sort of diagnostic telemetry that you're gathering about the device itself. Because when you're dealing with devices at scale, it's really, really good to have the device sending some, yeah, Mom, I'm still okay, data. Here's how I'm functioning. Because once you have a lot of them deployed, making sure that the device itself is reliable is really important. But the other thing about telemetry first is if you do telemetry first, then you have an opportunity to do so a little more safely in general. Like if I think about, go back to the connected vehicle example again. If my car is hacked, but the car is configured only to send telemetry, well, then somebody could determine my GPS location, which would be annoying, but not frightening. It'd be extra bad if it was a public figure. But, you know, that's a scary thing, but it's only sort of scary. If somebody can send commands to the vehicle while I'm driving it, that's way scary. And so starting with telemetry is, you know, a way to work through all these issues around security, management, when the stakes are a little lower. Similarly, in a factory situation, if somebody can compromise a factory system and it's telemetry only, then maybe there's a chance of IP leaking. Like if somebody can get telemetry off the robot in a factory, they might be able to determine how many widgets my company makes a month. And that would be bad. But if somebody could actually make the robot do something, then that could potentially be catastrophic. And so that's, you know, those privacy and security issues are another reason that telemetry first is a real good idea. So if you think about telemetry today, I mentioned, you know, event hubs is a very high-scale way to bring data in. I could have used Storm here instead of Stream Analytics, but I chose to use Stream Analytics. Stream Analytics is a very powerful tool as well. So a pretty common pattern that we've seen a lot of companies do that are starting with telemetry is to say, I'm bringing a bunch of data into event hubs, and I'm going to go to Stream Analytics, and I'm going to do, maybe I'm going to split the data into two pieces. And in this particular case, you know, push data to blob so I can later run ML on it and try to develop insights from it. And in the other case, maybe go to SQL or go to a messaging system or go to something else where I'm going to take some more in-time processing on these things. So this is a really common scenario. And the two key components here are event hubs and Stream Analytics. So with event hubs, you have, like I mentioned earlier, you know, we're talking about trillions of messages a month now. Super high scale, configurable, supports HTTP and AMQP. So we have literally millions of providers that can send data to an event hub. And I'll show you a simple example of doing that. A lot of configurability and easy to plug into other systems. And in the demo here, I'll show you plugging it into Stream Analytics with no code. Then Stream Analytics gives you the ability also to manage systems at high scale, millions of events per second, and really powerful programming model where you say, they made a couple of strategic additions to SQL with time-based commands to allow you to write queries that would really much be impossible to do otherwise. I'm pretty excited about this, and I'll show you in a moment. So I decided for the purposes of the demo to approach this like I was just some smart guy at a company, and my boss said, hey, check out this platform. So I didn't go in with a particularly Microsoft-biased approach. So I used JavaScript on a website to go generate some data, simulating the data coming from a bunch of machines. That data then goes to Event Hub. Event Hub gathers it up and sends it to Stream Analytics. I split the data at Stream Analytics. I just push everything to blobs. And then I do another more complicated query in Stream Analytics to find machines that the data would suggest were faulty. And I write those to SQL. Like I said, I could have written those to a messaging system. It's just really easy to demo them in SQL. And then to complete the loop, I have a worker role that which gathers the data from SQL and gives it back to me so I can display it in the website. Okay, so Let me switch over here. Okay, little website does a Monte Carlo simulation. You pick a distribution, a number of seconds to run, and a mean, and then it goes and generates data that fits that pattern. So pretty simple, just a few lines of JavaScript. At the end of what that JavaScript then produces is a little easier to see over here. What the JavaScript produces then is just a little event body with a reading, which is a floating point number, and a device ID, which is an integer. So if I go back here and now go into the Azure portal to create an event hub, I have a service bus namespace, which I created called Kevin Mill Demo, NS for namespace. And then inside the namespace, I can create an event hub. And when I did create this, I just hit the plus sign, selected event hubs, and quick create. And the quick create, all you have to do is specify a name for the event hub, and you have to refer back to that service bus namespace, which is automatically put in here, and then a region that you want that thing to run in. When you're building these solutions, you end up putting a bunch of services together, and it's a lot more efficient to have those services all in one location, at least at the scale that I'm talking about here. So I did create that event hub. And then inside the event hub itself, I created this beautiful swirling blue thing. There we go. I created a shared access policy for send and consume, so I can generate a key. So then I could go back to my code here. So I have the little JavaScript that generates the distributions. This is the kind of reversed chi-squared one that I was using. And then I have a few lines of JavaScript where I send that event body, which is what I showed in the slide. I create the message, which basically just serializes it to JSON. And then I do a send message to send that message to event hubs. And that's really the entirety of the code there. If I go back to the PowerPoint, and in the interest of dirty laundry and me really trying to do this like I was somebody from outside, my team has not yet released a JavaScript client for Event Hub. It is coming, but it is not yet released. And so I used one that was written by a Microsoft MVP named Damir Dobrik, and it worked great. But really, there's just these three calls to create a new client. So there's Kevin Mill Demo is the name of my Event Hub. Kevin Mill Demo-ns is the namespace, and then the SAS key was the one that corresponded to send telemetry, which I created in the UI. So I got just a very small number of lines of code there, then serialize it and then send it. And so for pretty minimal effort, then I'm able to send data up to the Event Hub. And I could run that data. I could run that Event Hub right now, but instead I want to show you the next piece of it first, which is that I want to connect it now to Stream Analytics. So if I go back to the portal, I have a Stream Analytics job here. And again, the creation of Stream Analytics, super easy, where I click New, and Data Services Stream Analytics Quick Create. Give it a job name, a region, and I have to have a storage account in that region where the monitoring data is stored. But again, just a couple of clicks and I have a Stream Analytics job. So then what I do with Stream Analytics is I configure an input, an output, and write a simple query. In this particular case, the input is my event hub. So Kevin Mel demo, there it is again. The output is blob storage, because this is the one where I'm just going to stash everything for later ML analysis. And then you write a query. And this first one is like the simplest possible query. It's just a few lines. It's easier to read here, where I select the device ID, the reading, event process time, from the event hub and send it to the blob. And that's all there is to it. I could have done select star from to, but I wanted to expand it here so you could see that I pushed in two pieces of data. I pushed in the device ID and the reading. And Event Hub tagged that package on the way through with a UTC date time for when the Event Hub processed the data. And so now I have the data here. So if I go back now and run, this thing again, data will be created, and I go over to the Azure Storage Explorer and do a refresh. Thanks. See, I told you I had not had enough caffeine this morning. I was not lying to you. So now I go over to the Storage Explorer. I open up this blob as text, and I see that I have this series of JSON objects where I have the device ID, the reading, and the UTC date time. So that's obviously a very trivial example. So let me go back and show you something that shows a little bit more of the power of stream analytics. So now, for the purposes of the demo, I'm assuming that based on the data that I've observed, either of my own experiences or maybe from what I find from ML, that if I have devices that give high readings within a short window, that's a bad sign that that device may be going to fail. And so the stream analytics query then says, I want to select from that data stream, I want to, the same data stream, the Event Hub. I have multiple queries running against the same Event Hub. In this particular case, there's a new bit of content here which is timestamped by event process UTC time. So I'm telling Stream Analytics that that field coming in is the important date field, and it ought to use that for date calculations. And then I'm going into alert counts, which I'll show you in a second, as a SQL table. And then the other thing that's an extension here from standard SQL, you can see is in this group by clause. So it's just where the float reading is greater than 115 and the count of those occurrences is greater than 1, I want to show the device ID and the count of times that it gave a high reading within this sliding window. And there are at least 3 different ways that you can specify a Stream Analytics sliding window. You can say, I want non-overlapping windows of a certain length, 5 minutes, 2 hours, 15 seconds, and those windows abut but don't overlap. You can specify overlapping windows that overlap in a specific way, like I want every one to overlap by 2 or whatever. Or you can specify a sliding window where for every event comes in, it recalculates the window back from that event for the time period. And I chose to do that one here. So this clause then gives me any time there is there's more than one high reading in a 15-second period, write it to the SQL table. And one of the things that I was thinking about, so there's a very small number of lines of SQL there. That would be a real pain to do in regular SQL or in a programming language, because managing the window and the counts within the window would be, a big challenge. And then I have, and I'll show you this in the tool in just a second, I have a second select statement here, which just takes the same data that went to the blob and sends it to a different, the same Event Hub input, but sends it to a different SQL table. So you can actually have multiple select statements within one Stream Analytics job. So now, if I flip back over here, there's just the same queries in the Stream Analytics window. So Stream Analytics is running now. So 2 jobs are running, because the blob one is still running. And if I go over to SQL, make sure it's empty. Okay. So now I can rerun the sample again. And now I should see the data showing up in both places. I should see a new blob table, a new blob in there that's got information. And now if I go to SQL and rerun the query, now I see the result of the second select statement, just putting everything in a table. That's the top there. And then at the bottom, I see that device ID 69 had 2 within a 15-second period at one point, and device 21 had 2 within a similar period. So I refresh, and I see a little more data there. So at this point, now I'm pretty close to completing the loop. Now I have the data going into blob storage where I can get back to it. I have the misbehaving devices identified here and an easy way to get information about them. So now if I go back here to Sublime, I just have to write a little worker role to do something with that data. So in this particular case, I have a function in my JavaScript that says get Stream Analytics results. That just does a post to a node.js server, which will then respond with that information. And so I can come down here, get the data, process it. So then I create a node job. So here's the node code for get Stream Analytics results. And then as you can see, it takes an input, which is the date time that I started the run, because I want to make sure I don't get any old data. And then it just does a SQL query using the SQL node extension to go get the device IDs that were flagged. So now if I start the node job, so I'm actually listening for the data, and go back and run this sucker one more time. That should complete the loop. So the data goes to blob, the data goes to SQL. Then my worker role picks the data up from SQL and lets me display it back at the site. So unless I forgot to pay my demo gods bill this month, after this runs for a few seconds, we'll see some devices start showing up there. So device 83 had 2 high ones. Device 27 had a bunch of normal ones and 2 high ones. And now, if I was doing this in a real production setting, what I would do is some messaging system there and send an alert to an operator, or maybe send a command back to the device itself to say, you're running hot. I need to turn you down. So if I go back to kind of thinking about the demo all up, the key takeaways, I think, that I'd like you to take away from the demo part of this talk are, it really wasn't very much code, right? It was a few lines of JavaScript that I used to generate some data. If you use our client libraries, it's a few lines of C or Java or C# or whatever. But generating the data is pretty trivial. There was no code involved in setting up the Event Hub and Stream Analytics and connecting the data through to Stream Analytics. Then in Stream Analytics, I wrote a few lines of code, but it's really powerful what you can do there. Obviously, you can go to Hadoop or something like if you would prefer, Storm if you would prefer. But you have a lot of options there. And then I had a few lines of worker code to take the data that was discovered by the Stream Analytics query and do something with it. But you can really get something going very quickly. And again, I focused on doing this telemetry first, thinking small. But while thinking small, you have to also be planning for bigger. Because you really do not want to build an architecture around the small stuff and then go, OK, now I'm going to have a life event to scale the thing up. Which is why building on something like Stream Analytics, Event Hubs, highly leveraged, because that will linearly grow with what you're building. Santosh did a talk on Stream Analytics the other day, and he did this online thing about guessing the age from a picture, and it went viral. And they went from having, a couple of people in Redmond kick the tires on the thing to many millions of people hitting it. And they had no scale events. He didn't have to mark out those 4 days when it got picked up by all kinds of media and got everywhere. He didn't have to go, those were the black days where I had to spend all day in the office every day, because he had built on scalable components using Event Hubs and using Stream Analytics. So speaking of Event Hubs and Stream Analytics, this brings me to my third pattern, which is don't stick your head in the fire hose. And the thing here is some of these components, if you're using these components that are built for cloud scale, it's astonishing how much information they can move through. And so it would be a really bad thing, unless I really knew what I was doing and really had to do it, for instance, to do my own processing between Event Hubs and Stream Analytics. Because those are both super high-scale systems that can do millions of operations a second. And if I put a worker role in there, I would just instantly bottleneck the thing, and I would be on the other end going, this stuff's supposed to be fast. It is really slow. And it would be because I stuck my head in a fire hose. Now, if you know what you're doing, and you can build, and you can handle that scale, obviously that's a completely different thing. But, I almost made this mistake myself here when I was doing this demo, because at one point I thought about doing a little data massaging. And I thought, not going to do it there. Right? Do it before the fast path starts or after the fast path ends. And you've probably been able to tell by how many times I've mentioned security along the way that another pattern here is about defense in depth. And this one is critical. Microsoft has a lot of experience and a lot of pain many years ago, where we went from not understanding to understanding how hard this is and how you have to think about it at every phase. We have mandatory security training for everybody. And it's important because you have to think about these things all the way through. I think I talked about connected vehicle scenarios a little bit earlier, but if you don't think about a state machine on the device that says there are some times when I am not listening to commands, then you're potentially creating security nightmares. I don't want the car to be able to turn itself off while I'm driving it. I don't want the robot surgeon to say, oh, this seems like a good time for a firmware update because the cloud told me I should update my firmware. I don't want it to do that while it's operating on my spleen. I want the local device to have some smarts. And more, I want some of the stuff that I can currently do only in the cloud to be done on the device. I want the device to do sort of a local ML where it says, I just got a bunch of commands that are really different than the commands I usually get. I'm going to phone home and make sure that we still have a good security connection and we still trust each other. A trivial example of this sort of thinking from the non-IoT world is banking. I don't want a lot of extra hoops between me and checking my balance. And if that gets hacked, somebody knows how much money I have in my checking account, really not the end of the world. But if I suddenly, try to transfer $10,000 to Elbonia, right, then I want the bank to send me a text message and say, is this really what you wanted? If it is, type in these 6 digits. And that's exactly the sort of thing that we need to do with the devices, too. The device needs to go, you know what? Maybe I have a function that lets you deploy the airbags because I needed, because somebody built that in sometime. But you can't actually run that function when there's somebody in the car. You can't run that function when on the highway. And that sort of local focus is something you have to build in at the beginning before you ship the device. That it knows when to double check, when to phone home, when to do things differently, how to recognize that it's in trouble maybe. And so you have to have this focus all the way from the very beginning. We have in our spec templates at Microsoft, there's a big security section, a big mandatory security section in every spec template. So, because we want people thinking about security at the very beginning. And then, I can't sort of overstate that this is not something you can vendor out. Security is a shared responsibility between any vendors and you. And if you're going to put stuff on the internet, you have to saddle up and say, you know what, I'm now going to be an internet security expert because that's my only choice. So then as you look at the device, at the data that flows through the device, you also have to think about this. Where are the security boundaries? How do I manage them as tightly as possible? How do I think about the physical security of the device, how hard it is or easy it is to tamper with? How I think about the protocols that I'm sending, how I make sure that if it gets rebooted, that's safely done. How I think about the application itself, the data, the privacy of the data, all the way, every step of the way, you have to have a security focus. And the benefit is high in a lot of cases, but for everything that you do, you have to think about that trade-off. What is the cost benefit? What is the security risk? And is the business value dramatically greater than that? Which is kind of goes back to the thing I talked about earlier about doing telemetry first versus command and control. Because you may find that the telemetry is really what you need. And the command and control requirements are actually very small. And you want to manage those as tightly as possible. So now I want to move a little bit to what's coming. Everything to that point is really stuff that exists today. So there's a thing that we announced Satya announced at the Convergence Conference in March called the IoT Suite. And the suite is really our effort to simplify the deployment, configuration, ongoing management of solutions. And it's a way for us to move to a solution focus as opposed to a component focus. And if you think about that slide that I had way back at the beginning with all of the Azure components, all the storage options, all the visualization options, analysis options, really what we want to do here with the suite is say, pick a scenario and we will instantiate a full solution around that scenario. And then you can customize from the solution. It's a little bit like the grown-up version of a Visual Studio project file. You go, I want to do a new project. You get one that will build and run right away. And then you go in and go, here's the to-do where I add my own functionality. There's a little bit of that, because what we want to do is instantiate common scenarios and then provide the ability to go and go, okay, you know what? Yeah, you put Stream Analytics in there. I want to use Storm. Okay, well, that's pretty straightforward to pull Stream Analytics out, replace it with Storm. Or I want to use a different storage option, again, to make that easier. To make the whole thing more predictable, we're also making some changes to the business model to make billing more predictable. So you can do more classic, longer-term budgeting against this. And then we'll continue to extend the scenarios, and we'll continue to extend the underlying functionality so we can easily scale to millions of assets under management. And the way we think about this, and this is a little bit related to that early picture that I had about with the devices on the left and things on the right. This particular slide, I don't think has any actual product names in it, and that's intentional, because this is kind of the way we think about these solutions internally when we build. You have devices and data sources. Some of those devices can easily talk straight to the cloud. We have an agent library that will sit on those devices that allows you to easily configure the capabilities of the device, get that information in, send commands and controls back. Those libraries also run on gateways if you have a gateway that's projecting the functionality of a bunch of devices behind it. So that's something that we provide that allows easy connection, easy command and control. And then once you get to the cloud, you can do whatever you like with the data and the analysis. Again, we're going to pre-populate these for common scenarios. And if you think about the little demo that I did there, you could replace Cloud Gateway in this picture with Event Hub, because that's what I used. The control system worker role at the bottom was my Node.js system server. I used Stream Analytics there for Stream Event Processor. I wrote some stuff to storage. I didn't have anything on the far left of this because I was doing everything that I did here with the virtually created data. But that demo conformed to this, and that really is like the fifth pattern here, which is if you build to the reference architecture, then as the IoT suite comes online, and some of that's starting to come online pretty much immediately, then the migration to the suite is really easy, and you just start getting stuff for free. You get new functionality for free. So the suite really has a couple of major components. One is that client library that I mentioned earlier, where we make it easy to get the data on and get commands and control back out. It's very easy in the library to describe what the thing can do. Like the thermostat example, is a trivial one, but in the library you could describe, I have a set temperature function, I have a report temperature function, I have an actual temperature function, maybe. So that's important, and we've built those things. They're written in C99, so they're really portable, and they run on very low power devices. We have it running on, I think the lowest power device that we have it running on is a thermostat, a really kind of not high-spec thermostat. And then we have it running on lots of bigger things too, obviously. And then the IoT Hub, and there's a talk by Elio DiMaggio about the IoT Hub. The IoT Hub extends the functionality of event hubs. So now you actually have identity management for the devices. You have overall device management. And you have command and control in addition to the ingress power of event hubs. And IoT Hub also has the low latency ACK, command and ACK that you need for a lot of these scenarios where you want that precision to know that the device received your command and acted on it right away. So anyway, if you build, like I said, if you build this way, then you get a very quick and easy onboarding to the suite. So let me do a really brief other demo here, which is going to be me typing my password again. So I have a BeagleBone Black up here, and I used the client library that for event hubs, not for IoT Hub, but the client library for event hubs to send information from the BeagleBone, which is running Debian Linux, up to my event hub and back in the system with the rest of the stuff. So let me find the right spot here. So what the client library lets me do is specify a connection string, and that's that same event hub connection string that I used, obviously, in the other part of the demo. The name of that event hub within that service bus namespace is Kevin Mel Demo. Then I have a couple of three functions that are provided by the client library. One is to create a data handle, which now has my message content. You can see that this is C code. There are higher level language bindings on top of this, but we support, the bottom level is C because C will run on really low powered tiny devices. So I have this event data handle that I create. Then I create an Event Hub client from the connection string. And then I have a send message. There's a send message that does a single send, and there's also a send message that does a batch of sends, like an array of messages if you want to send multiples at once. And we just added that functionality a few weeks ago because one of our clients wanted it. And because it's C, then I actually have to clean up after myself. But again, just a few lines of code where I create the message and send it in, this time in C. I have a Java version 2. So now if I go to PuTTY on a client here, then I can run, this is in the Debian Linux BeagleBone. Now that I have my demo built there. So now if I go back to this sucker one more time with feeling and run it, and then I go over here and run the Debian version. And I have the Debian version just sending data every few seconds. And again, a device ID that's an int and a reading, which is a trimmed float. So that data is now going into the same event hub along with this data. And now you see at the bottom of the screen here, let me zoom in on that a little bit. I assigned the Debian box an ID over 500 so I could find it easily from amongst the other data. And so you see now that as the system runs, I get the data from both of those machines. And again, by making a pretty simple addition, I now have a few lines of code again. I have data coming from a physical device in addition to the virtual devices. And now, in the picture that I had on the slide here, I also added Power BI. And so I have now this path from the demo, from the real device. And instead of going back out to my worker role, I can actually create a Power BI dashboard. And I think I forgot to start this running, so I think this is data from when I did it a little bit earlier. Yeah, this is data from when I ran it a little bit earlier because I forgot to restart the service. But so just quickly, without doing anything really at all, I can see that I have device 582 really spewing horrible data, apparently. So that would be clearly one to dispatch the tech for. That's my BeagleBone box there again. But so kind of this replaces a bunch of that presentation stuff that I built the hard way on my website by just pushing the data to Power BI and then clicking a couple of boxes and dragging the fields. And so I think there's a lot of work here that's really going to pay off in a lot of these scenarios to allow you to simply build real solutions that manage the high scale that's required. All right, so just to summarize here. So the summary is kind of sort of these 5 points, right? When you think about these things, think about the architecture and the component scaling, but start with small numbers of devices. Start with virtual devices or even, but learn or, experiment, learn, refine. That is a really powerful thing to do here. Again, starting with telemetry because it's just safer for one thing, but you're going to find insights in the data that you didn't expect if you follow the pattern that most did. Don't stick your head in the fire hose. If you have high-scale cloud components, don't put something in between them unless you know what you're doing. You got to be just relentless about security. 5 years ago, if you wanted to hack a car, you had to have physical access to the car. And Vito might find you breaking into his car and beat you up. And if you succeeded, you had won. If there are 1 million internet-connected cars, that's a different hack target. It's the same thing for buildings, houses, connected cities. You just have to think about security differently, and you have to think about it through the entire life cycle. And then finally, if you build toward the reference architecture, if you build today and you build toward the reference architecture, then it's going to be a lot easier to move to the suite. couple of notes. I mentioned Sam George's talk on creating the Internet of Your Things. That was on Monday. So if you didn't see it, obviously, it is available online. On Friday, Clemens Vasters is doing Security Fundamentals talk. And this 4554, Connecting Your Devices to the Azure IoT Suite, it's a little bit of a fuzzy name, but that's really about the IoT hub. So that's a drill down on how we're extending event hubs to allow identity management, device management, command and control. Elio DiMaggio is doing that talk. That would be a really good one to see. And then finally on the security thing, one last time, there's a case study on Microsoft's site about the experiences of a company called Itron when they moved to the security development lifecycle model. And it's a short paper. It's a very good way. It's kind of a walkthrough of somebody who's not us and their experiences in moving security to the center of their development practices. So I think I just have a couple minutes left, so I will just take, if you have questions, just come up and I'll try to answer them here. Thank you very much.